Hi, my name is Alex Millender.
And I'm Willy and I, and for our senior design, we designed a base station for an autonomous snowplow. And the other members of our group are Brandon Pritchett, Andrew Linen, and Kyle Zemer, and they could not be with us due to the coronavirus pandemic that we're in right now.
Hey guys, so this is just going to be kind of a generic overview of our project right now. I'll dive into some of the parts here. So we're using a 12 volt 8 amp power supply, and this will power everything you see here. We also have a 7-inch touch display, which is pretty nice. We created this custom GUI to display all the information about the charging station. You can see we've got its standby mode, it's not charging, and our stepper motor is not moving. You can also exit, stop charging manually, or manually charge the robot whenever you want. You can see we also have date, time, and charging progress bar here. You can also see we have the CPU temperature in the upper right corner. We are using the Raspberry Pi 3 as the main brains behind this operation. Here is a custom PCB that we developed and ordered. It's got a couple level shifters and different power supplies that will power our different components you can see here. We have 2 limit switches, and these limit switches act as reference points for the stepper motor. So on startup, the motor will go to one of these steppers so we know where the motor is in case of a power failure. The stepper could end up anywhere. So every time this gets started up, we send it home to one of these limit switches so we know exactly where the stepper is at all times. We have 2 sonar sensors here, and these sonar sensors act as detection of the robot. So once the robot will come over our base station, these will detect that it's within so many inches and then trigger a sequence of events to raise stepper motors and whatnot. We have an Arduino Nano here, and what this does, it really operates as a bunch of operational amplifiers. So we get LED signals from our battery charger here. These LED signals you can't see them, but underneath here we have photoresistors. We feed that into a voltage divider, then that analog voltage is fed into this Nano. That Nano deciphers that analog voltage and determines whether to drive a digital input or output, and send that to the Raspberry Pi. We have our stepper motor driver here, which controls our stepper motor. And that is kind of a large overview of what each component does. So this is kind of a more in-depth on our custom PCB that we developed and ordered. So as you can see here, we've got a 40-pin header that has female inputs on the other side, so you can plug and play with this with any 40-pin Raspberry Pi. Right here we have 2 level shifters, and what these do are shift signals from 3.3 volts on this side to 5 volts bidirectional. The Raspberry Pi takes 3.3 volts, and all of our other sensors are 5 volts. So we had to order 2 of these so we can convert all signals from 5 to 3 volts. We've got a capacitor right here, and this was actually, we found that on our pulse width modulation for our stepper motor driver, we were getting a lot of coupling noise, so this helped reduce that coupling noise. We've got 3 buck converters here. Each one takes in 12 volts, and these 2 output 5 volts, and this one outputs 3.3 volts. So the first one here outputs 5 volts, which directly powers this Raspberry Pi and our 7-inch touchscreen display. We have another 5 volt power supply here, and that powers all 5 volt rails on our sensors, so anything that needs 5 volts besides the Raspberry Pi and the touchscreen display is powered off this. And lastly, we have our 3.3 volts, which power this side of the level shifters. So that's a little more in depth on the PCB itself.
So here's our original housing for all of our components for our project here. So what would happen is the robot would drive over this bottom part, and the sonar sensors would detect that the robot is there, which would trigger the stepper motor to raise the arm. And then on the arm, it has copper contacts that would make contact with the bottom of the robot and ultimately charge the robot.
so this is kind of a general overview of our senior design project, the autonomous vehicle base station. As you can see, I just plugged in the power supply, and this program is designed to run on any boot up or power loss. So say if there was a power loss, you can see the arm is not in its correct position. Initially, the arm will go back to its home position, and once it hits this limit switch, it'll trigger an interrupt and tell the stepper motor to stop, and then we know exactly where the stepper motor is and that it's in its correct home position. So it'll send the stepper arm or the swing arm home, and once it's in its home position, the limit switch is pressed, and we know that the program is, or the arm is in its correct position and the program is ready to start. So once the robot is covered by these two sonar sensors, the arm should swing up and make contact with the copper pads that we are going to place on the bottom of this robot. Once that copper pad, or once this charger here makes contact with those copper pads, it will tell the stepper motor and arm to stop via this Arduino here that we set up. So I'll simulate this robot coming over these two sonar sensors. So it comes over, and once they're both covered, the stepper motor arm goes up and stops. So here we're simulating charging as the arm has made contact with the battery of the stepper motor. Now you can see that it's charging. We've got 25%, and this is fed from the Arduino and the LEDs on this battery charger. So it will just sit here and charge. Once it does hit 100%, we have it programmed to send the arm back home and wait until the robot leaves and comes back, and it will repeat the cycle. Here's some other features that we built into our senior design. So let's say if you came and wanted to manually charge your robot, or for some reason the sonar sensors were broken, we have this manually override charge. So if you press that, it'll prompt you, are you sure you want to manually override and charge the robot? Yes. You can see the arm will go up. Another feature is this runaway limit switch. So let's say if for some reason your robot wasn't there and you hit the manual override, it would hit this button, send it home, and wait for you for the real robot to come. So again, if you manually override it, there is no robot, so no contact is made. It'll keep running until it hits this limit switch, which flips the direction, sending the arm back to its home position. Another feature that we added is, say you're charging and you make contact. So now you're charging, and say it starts snowing outside. You want to go and make your robot go plow even though that it's not 100%. You can hit this stop charging button, and once it's done charging, it will send the arm home, and then your robot will be allowed to go out and plow your driveway. So those are some of the additional features we added into our project.